Good morning, students. So today's our topic is chapter number 3, atoms and molecules. In this chapter we're going to study about atoms and molecules, how atoms were discovered. So today what our topic is chapter number 3, atoms and molecules. So in this chapter we're going to study about atoms and molecules, how atoms were discovered. So today what our topic is chapter number 3, atoms and molecules. In this chapter we're going to study about ancient philosophers and molecules, how atoms were discovered. So today what our topic is chapter number 3, atoms and keep on dividing matter. We got a stage that the matter is not further divided. That stage is called atom. Atom is basically a smallest unit of matter. Everything in the universe is made up of atom, because every matter, everything we can see is made up of atom only. Okay, so there are some laws, there are some chemical laws which define the atom, which show the properties of atoms. So let's see that laws. So the laws of chemical combination. First law is law of conservation of mass. Law of conservation of mass states that mass can neither be created nor be destroyed in a chemical reaction. Whenever there is a chemical reaction is happening, mass can neither be created nor be destroyed. Like example, if we talk about in a chemical reaction, we have seen that reactant make products. We have studied in our previous classes that reactants make products. If there are some mass in these reactants and if there is some mass in the product, mass will be same, because this is the law of conservation of mass, that mass can neither be created nor be destroyed. Suppose there is a chemical reaction taking place, like in this activity. We have taken some sodium sulfate solution, you can see here sodium sulfate solution in a conical flask and some barium chloride BaCl2 solution in an ignition tube. We have hung the ignition tube in the flask by a thread and a cork on the flask. Find the mass of the flask on a balance, then till the flask a chemical reaction takes place and sodium chloride and barium sulfates are formed. Then find the mass of the flask again. It will be seen that the sum of masses of the reactant and products remain unchanged. So what basically is happening in this activity, we have taken two solutions of barium chloride and sodium sulfate. Okay, sodium sulfate we have taken in a flask and barium chloride we have taken in a tube. Okay, we have measured these two substances. Suppose the mass is 300.23 gram. Okay, after the reaction we have shaken the flask. You can see here we have shaken the flask. A chemical reaction has taken place, and when the chemical reaction has taken place, the mass remains the same. So this is our law of conservation of mass, that mass can neither be created nor be destroyed. If mass have been destroyed, our weight could be less. This 300.23 gram weight could be 200 or 250 gram if the mass is destroyed. So mass is not destroyed, mass will remain same. If the mass is created in a chemical reaction, that means this weight could be more, but the weight remains same. So we can say that this law is correct, that is law of conservation of mass. This is our reactants and this is our product. Okay, so this is our first law, that is law of conservation of mass. Let's move toward our another law. Second law is law of constant proportion. It states that in a chemical compound the elements are always present in a definite proportion by mass. Whenever there is a compound, the elements in a compound are basically in a same proportion or in a same ratio. Suppose if we take an example of H2O. If we take an example of H2O, you all know what is H2O. H2O is a chemical formula for water. Now in this water, hydrogen and oxygen are in the ratio, hydrogen and oxygen are in the ratio 1:8. Whatever the mass will be, the proportion will remain same. Suppose I have taken 9 gram of water. Suppose I have taken 9 gram of water. In that 9 gram of water, according to the law of constant proportion, the hydrogen and oxygen are in the ratio 1:8. So if I divide this 9 gram into 1:8, I am getting 1 gram and 8 gram. I am getting 1 gram and 8 gram of this 9 gram water. That means 1 gram is of hydrogen and the other one is oxygen. The 8 gram is oxygen and 1 gram is hydrogen by the mass. Suppose I have taken, instead of 9 gram, I have taken 900 gram. I have taken 900 gram. Then also the ratio will remain same. If I divide this 900 gram, 100 and 800. 100 gram is hydrogen, 800 gram is oxygen. So this is our second law, that is law of constant proportion. Whatever compound we are taking, compound we have studied in chapter number 2, that compounds are basically when two or more elements combine together we get a compound. So these are two elements, and hydrogen and oxygen, when they combine together they make a compound, and in a compound the ratio of their mass is always proportion. We have seen here by this example. Okay, this is the example of H2O water. Next example, if we take ammonia. Okay, first see this. Water H2O always contains two elements, hydrogen and oxygen, combined together in the same ratio of 2:16 or 1:8 by mass. If 9 gram of water is decomposed, we get 1 gram of hydrogen and 8 gram of oxygen. Now, second compound we talk about ammonia. These are the water molecules. You can see here 2 hydrogen and 1 oxygen. Now NH3, ammonia. In ammonia, the nitrogen and hydrogen combined in a form of 14:3. If we talk about ammonia, nitrogen and hydrogen combined in a form of 14:3. This is the ratio of ammonia, that is nitrogen and hydrogen. Okay, so this ratio will always remain same. Whatever the quantity, whatever, suppose I am taking ammonia as 1700 gram. I am taking 1700 gram ammonia, then 1400 gram is of nitrogen and 300 gram is of hydrogen in that, because this ratio will always remain same. Okay, this is our second law, that is law of constant proportion. Understood? So two laws we have understood right now. Law of conservation of mass, that states that in a chemical reaction mass can neither be created nor be destroyed, and the second law is law of constant proportion, that in a compound ratio will always remain proportion. Okay. Now these two laws given by Anton L. Lovister has given these two laws of chemical combination. By seeing these two laws of chemical combination, Daltons, a scientist, made his atomic theory. On the basis of this atomic theory, the atomic theories have 6 points. Okay, let's see what Dalton's atomic theory states. First is, matter is made up of tiny particles called atoms. We have studied while at the starting of chapter that every matter is made up of very tiny particles. These tiny particles are called atoms. Second, atoms are indivisible and cannot be created or destroyed in a chemical reaction. Atoms are indivisible because we reach a stage where the matter we cannot divide further. So there is that stage called atom. So matters are indivisible and we cannot create matter or we cannot destroy matter. Okay, they cannot be created nor they can be destroyed. Third is, atoms of a given element are similar in mass and properties. Whatever the atoms of a given element, they are always be similar in mass and properties. Suppose there is one atom of oxygen, there is another atom of oxygen, both have same mass and both have same properties. Okay. Next, atoms of different elements have different masses and different properties. Of course, if I am talking about oxygen and hydrogen, both are atoms, both have different masses and both have different properties. Okay. Next, atoms combine in small whole number ratios to form compound. Atoms or element, they compound in whole number to form a compound. Okay. And the last is, in a given compound the relative number and kind of atoms are constant. This we have studied the law of constant proportion, that the ratio will remain always same when atoms or element they are combining with each other. This is the Dalton's atomic theory. You can take screenshot of this Dalton's atomic theory if you want. Okay. Let's talk about atom. Right now we have discussed the properties of atom, how atoms are combined, we cannot create them, we cannot destroy them, how they are combining in the same ratios. When Dalton has given this his atomic theory, what he is described in that atomic theory. Okay. Now what are atoms basically? An atom is the smallest particle of an element that may or may not exist independently and retain all its chemical properties. Atom we have discussed is the smallest unit of a matter. Okay, it is the smallest particle of an element that may or may not exist independently. Atoms cannot exist independently, okay, and they retains all its chemical properties. Atoms are very small in size and smaller than anything we can imagine or compare with. Atoms are so small that we cannot see, or with our naked eyes we cannot see the atoms. If I give you an example of atoms, how small these atoms are, suppose we have seen a thick layer of paper. Okay, that thick layer of paper contains millions of atoms. That thick, very thick layer of paper contains millions of atoms. Okay. Atomic radius is measured in nanometer. Yes, atomic radius is measured in nanometer. How much the nanometer? 1 nanometer is equals to 10 to the power minus 9 meter. This is the atomic radius. 1 nanometer equals to 10 to the power minus 9 meter. This means that 1 nm equals to 1 upon meter. You can see 1 nanometer equals to 10 to the power minus 9 meter. This is the smallest radius of an atom. This is the atomic radius. The atomic radius of an atom of hydrogen is 10 to the power minus 10 meter. The radius of a molecule of water is 10 to the power minus 9 meter. If we talk about the atomic radius of hydrogen, this is 10 to the power minus 10 meter. This is the atomic radius of a hydrogen atom. Now you can compare how small is that hydrogen atom is. Okay. Now there are some compounds and elements given. This is carbon dioxide. These are the two atoms of nitrogen combined to form N2. Two atoms of oxygen combined to form O2 or oxygen we say. Two atoms of oxygen, one atom of carbon combining forming carbon dioxide. Okay. This is the example of methane CH4. One atom of carbon and 4 atoms of hydrogen. This bonding we'll study in the higher classes, how this bonding happen. Okay. And some bonding we'll study in 4th chapter also. Right now just study about the atoms. What basically are the atoms? Now symbols of atoms of different element. If there are some different atoms in our universe, of course there are different symbols to represent these atoms. So first some scientists came and they came with the different symbols. Okay. Like they came with a particular shape. Okay, suppose a hydrogen symbol is like this. So in this way they have given different symbols for different elements. Okay, so afterwards scientists came and they have make an organization called IUCN. IUCN means International Union for Conservation of, sorry, not IUCN, IUPAC. IUCN is different. IUPAC, International Union for Pure and Applied Chemistry. This IUPAC approve the name of the atoms. Okay, whatever the elements, whatever the symbol is coming, this IUPAC always approve the symbols. So the symbols of elements are represented by letters. The symbols of some elements are represented by one letter, and the symbol of some element are represented by 2 letters. For example, if I talk about hydrogen, hydrogen symbol is only represented by one letter H. Okay. If we talk about sodium, sodium letter is represented by two letters, that is Na. Okay. In the same way, you can see here there are different symbols given. Gold symbol is represented by Au, iron represented by Fe. Okay, in this way all the symbols are represented. The symbols of some elements are represented by one letter and the symbols of some elements are represented by two letters. If the symbol has only one letter, it should be written as capital letter, and if the symbol has two letters, then the first letter should be capital letter and the second letter should be small letter. This is the rule of writing the symbol of any element, of any atom. If we are writing only one letter, that one letter should be written in a capital letter. Okay. Suppose I am writing hydrogen atom, I should write hydrogen as capital H. If I am writing hydrogen as this small h, then it could be wrong. Okay. In the same way, if I am writing the symbol for potassium, potassium symbol is K. If I am writing like this, then this is correct. If I am writing like this small, this K, this is wrong. So this is our first rule of writing the symbols of any atom. Second is, if the atom contain two letters, if the symbol contain two letters, then first letter should be capital and the other letter should be small. For example, if I talk about barium, barium is Ba. This is the correct symbol for representing barium. If I am representing barium as this B, capital B and capital A, then it is wrong. We cannot represent the symbol of this like this. Okay. Next, I cannot write first letter as small and the second letter capital. If I am writing Ba like this, then this also wrong. Only this is the correct way. First letter should be capital, second letter should be small. This is the correct way of writing an element, okay, of an atom. Now there are some symbols given, okay, of some atoms, of some elements. Like aluminium is represented as Al, argon Ar, barium Ba, boron B, bromine Br, calcium Ca, carbon C, chlorine Cl, copper Cu. This is the symbol for copper. Fluorine is F, gold is Au, hydrogen H, iodine I, iron Fe. Iron is taken from the Greek word ferrium, okay. Iron Fe, lead Pb, magnesium Mg, nitrogen N, oxygen O, potassium K, silicon Si, silver Ag, sodium Na, sulfur S, uranium U. So these are some common symbol for the elements. To represent the element, we should write like this, okay. Now what should be the mass of an atom, because an atom is so small that we cannot measure the mass of an atom. So what scientists have done, they have taken an element and on the basis of that element they have defined all the mass of that atoms. Suppose I am giving you an example with a watermelon. Suppose a fruit seller having only one watermelon of 10 kg, okay, and he don't have any weighing machine with him. So what that fruit seller is doing, he divided that watermelon into 10 pieces. He divided that watermelon into 10 pieces of 1 kg each. So with that watermelon, he is weighing other fruits. Suppose he want to weigh 2 kg of apples. If he want to weigh 2 kg of apple, he is taking 2 slices of that watermelon. So in this way, with the help of watermelon, he is taking the weight of another fruit. In the same way, scientists have taken one atom of carbon-12. With the help of one atom of carbon-12, the scientists have defined all the mass of different atoms. Okay. Since atoms are very small in size, its mass is very small and determining its mass is very difficult. So the mass of an atom is compared with the mass of a standard atom. The atom which is considered as a standard form for comparing the masses of other atoms is carbon-12 atom, whose atomic mass is 12 mu. This is 12 mu. Mu means AMU. This is the SI unit, this is the unit, this is the unit for measuring the atomic mass. This is represented by AMU, and the full form of AMU is atomic mass unit. Okay. So the one atom of carbon 12 is 12 mu. This is the weight of one atom of carbon 12 atom. One atomic mass unit is the mass of 1 by 12, the mass of one carbon atom. So 1 mu is 1 by 12 the mass of this carbon atom. Okay, 1 mu is 1 by 12 the mass of carbon, that means 12. So 1 mu is 1 by 12 the mass of carbon atom. Okay. So in this way we have defined the atomic masses of different elements. So the atomic mass is given right here. Atomic mass of an element is defined as the average mass of an atom of the element compared with 1 by 12 the mass of a carbon 12 atom. Now the atomic masses are given like hydrogen has 1 mu, carbon has 12 mu, nitrogen 14 mu, oxygen 16 mu, sodium 23 mu, magnesium 24 mu, aluminium 27 mu, sulfur 32 mu, chlorine 35.5 and calcium 40 mu. These you have to remember. These atomic masses you have to remember. Okay, because these are the atomic masses of some elements. If we are defining any, if we are having any numerical, we have to remember these atomic masses. Okay, only 10 atomic masses are given in your course. Just remember these 10 atomic masses. Okay, mass of these 10 elements you have to remember. Okay. So basically today we have understood the properties of atom, how atom is discovered, what is atomic mass, how we have to represent the atom. Okay, these things we will study, we have studied in today's topic. In the next class we will study about the molecules, what are ions, we will define the molecular mass of a compound. Okay, in the next classes we will see these type of topics. So thank you everyone, have a nice day. I hope you all have enjoyed today's class. Thank you.